Imagine we have two conductive plates with air as the insulator between them. If we connect them to a battery and increase the voltage of the battery, as you see, positive charges would go on one of the plates and an equivalent and equal number of negative charges would go on the other plate. We say the capacitor has been charged by the battery. The amount of the charges with respect to the voltage that we apply is called the capacitance. And obviously, if we increase the area of the plates, it would be more area for the charges to go, so the capacitance increases. Also, if you decrease the distance between them, since you know how the voltage is defined as the electric field alongside the path, or the electric field times the distance, so you see the distance between the battery and the plates has increased. Therefore, the voltage has increased, and so we have more charges saved on this capacitor. Now imagine I disconnect this capacitor from the battery. So the charges don't have anywhere to go because between them is insulator. Now I connect them to a conductive path, through a conductive path to one another. And as you see, electrons would move from the negative plate to the positive plate and canceling the electric field or canceling the positive charges. Since they are going through the lamp in the path, they are heating up the tungsten between inside it, and therefore the lamp would glow. So we say energy, the capacitor saves energy in the form of the electric field. I always have had this problem that what does it mean that they say capacitor stores energy in the form of electric field, or inductor stores energy in the form of the magnetic field. Now, as you see, it's just like that. It comes from the fundamentals that as you see in this case, we say the capacitor is discharging. Let me actually show this to you again. So because of the area and the distance between the two plates, the plates could save some amount of energy if connected to a battery. The amount of the charges with respect to the voltage applied is called the capacitance. So you see, when we connect that to the battery would charge the capacitor by putting charges on the plates. Now, if we disconnect the capacitor from the battery, then the charges can't go anywhere. They don't have any conductive path. Between them is the insulator. So energy is saved. We say energy is saved in the form of the electric field. So I connect that to the battery, and once more, as you look, the electrons would move through this conductive path to cancel the electric field. And as I said, this would cause the electrons would move through the light bulb and would make it glow by heating it up. So the capacitor is discharging.